Okay.
Yep.
So did the maximum value contiguous subsequence, would you like to do a different one?
Did we solve that one?
I don't know. I would redo it.
Yeah.
You redo it as well.
Well, why don't we just go over it one more time?
Yeah.
That's good.
So in this one, your input is a set of values, A1, A2, AN. And you want to find the contiguous subsequence.
Oh wait, so was this the one where we would look at it in terms of like from the last element like to the I know we start with it has to do with like the recursive subsets and then I don't know how to explain it though. Like I have the
So, well, let's just try to figure it out in terms of what the subproblems ought to be. What are the subproblems? What is the recurrence? Okay.
it's like when you're talking about a subproblem, do you mean like comparing like smaller contiguous subset with like a bigger one and then moving on and so on?
It's kind of a little bit confusing, but so you're in your subproblem, you also don't know where the contiguous subsequence is. So
okay.
Your question is, what is the contiguous subsequence in here, right? But so yeah, your subproblem is a smaller array than this one. But what you actually want, and that's the part that's a little bit tricky, is that you don't want your subproblems to answer this question, because that's too hard. Because if you're trying to answer this question on the subarrays, you have to both find the starting point and the end point of it. Right? Because here it's what is the contiguous subsequence, what is the I, and what is the J that maximizes that. Right? So the key to solving this problem is to write out your subproblem so that it's a little bit different than this, in that you basically don't want that, you want that where J is actually fixed. It's the end point of the array.
Okay.
So the subproblem is a subarray from 1 to J. All right, so this is the question. You want a contiguous subsequence, but you want to maximize the sum going from some unknown value I to that fixed value J. That's your subproblem.
Did you say that J was the end of the array?
So this is the subproblem.
Oh, like the end of the subarray, right?
Yeah.
Okay.
In the subarray, this is your new input. It stops at J.
Okay.
And then amongst all those, you're trying to find the contiguous subsequence that's the maximum, but only among the ones that end at AJ. So that means that there could be smaller ones in here that have a bigger sum, but you don't look at those unless it ends at AJ.
Okay.
And the reason you want that is that if you don't end at AJ, you can't grow it, you can't do a recurrence, right? Because to be able to do the recurrence and growing your array from something you know to one more, it requires that you don't skip the one that's at the end. Because we want contiguous subsequences, that's the reason.
So when you're saying that the array is growing with every single step of the recurrence, are you saying that J is J still fixed and it's growing this way, or is J going to grow one more to the array?
J is going to grow.
Okay.
Yeah. When you're doing your recurrence.
Okay.
Right? In your subproblem, that's just one problem. And that's in the subproblem itself, that part is fixed. That means that what I'm trying to say is that in the original problem, you're given this, an array like this, right? So that's the given. And then you have to find two values. Right? That's the original problem. And what I'm saying is that if you try to express this problem in terms of smaller problems, if you're trying to find a recurrence where each of the subproblems also involve two unknowns, you're not going to be able to do it.
Yeah.
So instead, you have to do subproblems. Oh. The subproblems don't look like this, which is kind of different from a lot of dynamic programming problems that we looked at, where the subproblems look exactly like the original problem. It's just that the input is smaller. You're answering the exact question, the same question for the subproblem as you are for the original problem. So in this one, the subproblems look a little bit different. Here's your array that's given. That's like this, A1 to AJ. And then what you have to find is just one value here. Right? Need to find one value only. Because you're only looking at maximum sums that end at this point. Last endpoint is the same as end of array. In other words, these two are asking slightly different things, but that's what we have to do in order to be able to have a recurrence.
Is that typically the case?
So apparently in the ones that we've done, no, but it does come up.
Pretty often?
Yeah.
Okay. And so would the sort of like mindset of approaching a dynamic programming problem to be to, okay, like first ask what's the subproblem, then what is the recurrence, and then from there.
And actually those two kind of play together because we were trying to think of a recurrence, and we can't think of one in terms of the original problem. That's why we have to change our subproblem to be different from what would be the obvious. But it is similar to ones that we've seen before, in that the subproblems are not if you think of problems that are smaller than the input, there could be quite a few, right? Because it could be any subarray in here. But what we're looking at are only the subarrays that are prefixes of the original problem. So it always is from A1 to some value.
Could you flip the problem up like backwards and say from AN to some mystery value I instead?
Yeah.
Okay.
Yeah, it would be the same reasoning.
Okay.
So you could do it that way. But now you have this. What is the actual recurrence? Because we still don't have. So how we go? does it make sense that these are the smaller subproblems? Those are, and typically you don't need all of them, but those are all the possible ones that you could use to solve the subproblem here, right? I just listed all the ones that were small.
Wait, did that 1 turn into an I?
Oh, yeah, that's a 1. So what is the question in the subproblem? Oh, I didn't finish writing out the question. It's what is the contiguous subsequence starting from some midpoint in the array to AJ?
That has the largest sum?
Yeah, with the largest sum. So let's try to understand what the problem is. So here is 1, 2. Right, so here's our array A. And now the question we're trying to answer is not which is the subsequence that gives you the largest sum and that ends anywhere, right? And it's only amongst the ones that end at J. So amongst all those ones, how many do we have? How many subarrays that could be possible answers?
Is that that equation that escapes me? Like something times something plus like n times n plus 1, or is that another?
It's simpler than that.
Simpler than that?
Yeah. So how many different subarrays do we have?
J minus 1. J minus 1? Yeah, separate.
How many?
No? J minus 1?
J minus 1? Yeah,
Yeah.
right? So we
Just-
could be
Oh,
all
yeah,
of
yeah.
this. Right, so these are the ones. This. It's all the ones that end at J. Right.
So your final subarray, it seems it doesn't contain A1 all the way to AJ, right? It just goes up to AJ minus 1. Because, yeah,
Yeah.
you notice, okay.
Yeah, so
And that's because, I mean, you have AJ up there in red, so it just, is that part of the reason why?
that,
It's not part of the final subarray. Like,
Yeah.
you don't have another one below that, which is A1, comma, AJ.
that's the one we're trying to solve.
Oh, okay.
So we don't know that one, and we're gonna use everything except for the 1, 2, the ones 2, AJ.
So we basically want to know amongst all these different subarrays,
Yeah.
which is the one that gives you the maximum value,
Mhm.
right?
Okay.
And what we have at our disposal is different subarrays. We have, ending at here, we know that the maximum, so this problem, right? We know how, if we have an answer for it, that means that we know if our maximum subarray ends here, amongst all the ones that start over here, we know at what point we have to stop to get a maximum sum among all those that end at J minus 1. That's this answer,
Oh.
right? To this subproblem.
Okay.
It tells you where to start. But that only tells you where to start to end at J minus 1, not at J, right? And then you have other ones, for example, for A1, well, A1 is just this guy, right?
Yeah.
Let's do A12. So at A12, it tells you whether to stop here or to keep going to the start. Okay? So immediately, if we're looking for contiguous subsequences, right? We're still looking for something that's contiguous and that ends at J. All these are actually useless to us because all these encode subsequences that end at some value right here, and you can't use that to grow it into something that ends here, right? Because you have this giant gap. In other words, because we want something contiguous, these first few are useless for the recurrence. So now, instead, we look at J, right? We want to know among all these, again, which is the one that will give you a maximum. So one of the choices is just to take J by itself. That would be the shortest one, right? That would be one valid sequence, this one. But now suppose that we want to compare that to ones that are longer. Then my claim is that all you need to do is take the solution to this one and add this last value to it, and that those are the only two possibilities. Right, so the two possibilities are either
K of J
this
or
whole thing, right? Or just this thing by itself for the subsequence that end here.
so is that like the part of the recurrence where you like do like the max to compare the
That's
two
where you,
values?
yep,
Okay.
right? It can't be anywhere in between, right? Because if you got something bigger in between without this last guy, well, that would have been the answer for AJ minus 1. So it is whatever AJ minus 1's answer is, with or without that last one. Let's just write the recurrence. How do you write the recurrence? We need a variable or a table name, right?
Yeah. L.
L. And we have a value for, so how long and what's the dimensions of the table? How big is it?
As long as it's just going to be J.
Yeah? Or how about in terms of the input?
In terms of
Or if it makes more sense, how many different subproblems are there?
N minus 1.
Yeah? Or, so why the minus 1? Can we just do n?
Oh, yeah, because would N itself, oh, wait, would the problem itself be a subproblem, or?
No, so the problem itself is not a subproblem.
Okay. Why would it be N?
It would still be n, right? You still want a value for the longest subsequence that ends at n.
Okay.
So we do want L to be the array of length n. And what is the value that you're going to put in this array?
maximum of the whatever index you are at right then and there versus that value plus the subarray that comes before?
Let me be a little bit more explicit. So if I have just one value, like this,
Mhm.
what should be the value in L? L of 1. So if this is 3, what is L of 1?
Would it just be 3? Because, I mean, it's either
Yeah.
that value and you can't go any longer because you can't skip values.
Yeah, we basically want in general, it's not necessarily values from the array. Like in the change for the problem, it's not going to be that.
Okay.
It's not going to be a monetary value. Usually you want your L to represent some sort of a quality measure, right? Here we're trying to maximize a sum, so your L would be, you'd be keeping track of a sum basically. In the change problem, you're trying to minimize the number of coins, so whatever value you put in your table should be a number of coins. It's not like a dollar amount. It depends on what you're trying to minimize or maximize. But yeah, so in general, equality measure. Okay, so in this problem, L of J is maximum sum over all So in this case, it's a sum of values in the array. So that's what we're trying to express in this quantity in terms of subproblems. So what will it be? This is where we do the max part. What is it, the max?
Either A of J or A of J plus I guess A of some value, some other variable to A of J minus 1.
So we want to express this quantity here, right?
A of 1 to J minus, oh, sorry, that question mark, whatever that question mark is.
Oh, yeah, this question mark, right? So we're trying to say in the subproblem from A1 to AJ minus 1,
Yeah.
what is the maximum sum, right?
Yeah.
Starting from some value. How do you say that in terms of L?
In terms of L of J is, wait, I know it's the next sum. Would it be, what is that unknown value represented as in terms of a variable? Like, do we know that in terms?
It's L.
It's L?
Yeah, right? So the answer to this subproblem is L of J.
Oh wait, that's the
Maximum.
answer to subproblem.
The answer to this subproblem is L of
J
J
minus
minus
J
1.
minus
1.
one.
Oh, so
Oh.
L of J minus 1
Yeah.
Oh,
plus
okay.
L of J.
Yeah.
Okay.
L.
Oh, so sorry, plus, wait, yeah. Just L of J, right?
L of J, no, L of J is what we want.
Mhm,
Oh,
yeah.
oh, so what is the? What is that value then? Is L of J minus
So what are we trying to represent again? Could you say it again?
Yeah, so we're trying to represent the answer for finding the maximum sum from some value in here
Mm-hmm.
all the way to J.
Okay.
And we said that there were two solutions. Amongst all those, you only have to look at the subsequence that's a single value
Mm-hmm.
and the subsequence that's the answer to the previous subproblem, the one that ends at J minus 1, like this,
Mm-hmm.
and then concatenate that with the value right here.
So that's A of J. Would that be?
A of J is the value right here in
Oh.
that array.
Oh, okay. Then what's L then? Like,
Yeah.
are L and
L-
A the similar? Are they the same arrays or different arrays?
They're different arrays, right? Because A is your input.
Yeah.
And L is that sum,
Okay.
right? So that for example, for this subproblem,
Yes.
that's L of J minus 1. So basically, L of J encodes which of these will give you the maximum sum. It doesn't tell you where to start. Instead, it tells you what that value is of that
Okay.
maximum sum.
Okay.
So if this is maybe this one, oh, this one. If this one is your maximum, is the array that gives you the maximum sum, L of J tells you the sum of those guys,
Mm-hmm.
right?
Yeah.
So L is a one-dimensional subarray now,
Yes.
Yeah.
or an array.
Well,
Yeah.
so L and A are both the same dimension.
Okay.
Right? It's just that they represent different values. Yeah. So the key to LJ, why do we want this? It's because it's a quality measure.
Mhm.
To be able to build on the next one, you have to find the maximum, you want to be able to compare different sums for different arrays. That's why we encode this and not the actual index. But once you have this, you can also have a different array to include the index too. But this is, so the one with the index is the one that will give you your final answer.
Mm-hmm.
The LJ is the one that will allow you to move forward in your recurrence. So you kind of need both. Usually, in most problems, we don't deal with the index itself because you can always backtrack. But you can also do it while you're doing your work forward, because when you're backtracking, you're always trying to figure out, you're taking the max of different things, which is the one that is setting the value of that max. That's the one that you want to backtrack to afterwards.
So backtracking will find the specific answer, but
You will find the index.
Mm-hmm. Index.
So yeah, so the answer, because the question is, it's not finding the maximum sum, it's finding the subsequence. So in other words, finding the I and the J.
okay. But if the question were to ask what is the maximum sum of, say, this subsequence, like an actual application to this general problem, then you would backtrack to find your specific solution?
If it's just a sum?
If it's, I guess, like, not only the sum, but the numbers that it takes to get to the sum. too.
Yeah, then you need to backtrack.
Okay. So L of J minus 1 plus. Is it not just A of J?
Yeah.
It's just A. So L of J minus 1 plus A of J would be the maximum sum of the previous subsequence plus just that one value, right?
Yes.
So that would be the one.
So that would be one of the options.
And what
So-
about yeah.
Yep.
Go.
And then what's the other one?
Would that just be A of J?
A of J.
And then there would be base cases, right?
Yeah. Since we indexed at 1, the base case would be for L1.
It would just be A of 1. Right?
Yep. If your array is just that single value, the maximum sum you can have is just that single value.
Yeah.
So based on this, can you write code to fill out this table?
Okay, so it'd be for, let's see.
So you could start by instantiating the array.
Okay, so fill out the array so that like you have enough. Well, it depends. Build the array with length n.
Yeah. Put I in